What's going on, Facnatics? If you've seen the latest series of videos, you know I've been taking some of the industry webinars I host and repurposing them so everyone can have access to this great information. Today's webinar features industry experts Anthony Grimani and Matt Trinkline from StormAudio as we discuss the benefits of using the AES-67 and Dante platforms to build a networked audio theater. I got to see this build from the ground up during CEDIA and immediately decided I needed to build my new theater this way as well. This technology is rock solid since it's been a standard on the commercial side for years and offers residential users faster installation while minimizing errors and eliminating the potential for hum in your system. While our two expert engineers get a bit technical, this is actually really easy to follow along. And by the end, you'll understand why so many AV companies are starting to build this into their products. And if they aren't, they might be getting left in the dust. I'm Brett Bjorkquist, head Facnatic, and today we're discussing why networked audio is the future of home theater. I think the big thing that stuck out to me and why I really wanted to do this topic in particular was as we were leading up to CEDIA and sitting down with Anthony, we were talking a lot about networked audio. And then as we got to CEDIA and actually seeing it live and set up and the way that it was done, I'll let you guys kind of talk about it a little bit more. But frankly, I was blown away. 23 years for me on the professional side, starting at Good Guys. So I've run my share of systems. It's crazy to me the way that networked audio can simplify those installs. AOIP, networked audio, AES-67, Dante. It goes by a lot of names depending on specifically what it is. It's obviously been in the commercial side for a while, a little slower to pick up in the residential side. Sometimes as much as we're all about tech, we are about tech that we know, right? I think that's usually the best way that most integrators like to look at it is, I install what I know is going to work. Why do we need to talk about AOIP in residential systems? Why aren't we just fine using what we've been using, and why is commercial using it and we're not?
Ultimately, we need to talk about it because it's the way that the audio side of things is going to enter the 21st century. Somewhere around 2015, you could say, look, there's now plenty of people on the manufacturing side and plenty of people on the integration side doing this. So it's been a while. It's going on 10 years, and so for me, audio over IP is entering the 21st century. We're in 2023. We're almost a quarter way into this 21st century, but this is technology that brings audio from really old school 1960s, 1970s approach at stuff into the modern world of everything is computer based, everything is network based, everything is monitorable, everything is easily plug and play, and it's time to do it. There is a way to get to audio excellence way faster and way more predictably and way more reliably with technologies today. One of our strategies is always to streamline the installation process. The more complicated it is, the less chance there is that you're going to get to audio excellence. The more straightforward it is, the more you run a chance of getting there. And one of the ways to get there in our case is for our speakers to all be active so that you're taking out the uncertainty of what the amplifier speaker interface is doing, and to feed all of this with networked audio. In our world, we've decided to adopt either AES-67 or Dante, depending on the application. The demo we did at CEDIA was largely AES-67 based, and I will explain the difference between those two a little later. But both of those technologies allow us to drive all the audio through internet protocol, through a computer network, and do remote verification and monitoring of the entire chain of signals from source to destination. Make sure everything is working. Make sure that if there is a problem, we can monitor it and fix it by remote if that's the case. So the point is audio excellence. Okay. The point is not just to play with technology for the sake of, hey, it's new, it's fun, let's do this. The point is audio excellence. And you can get audio excellence with analog. I do want to point this out. I'm an old school analog guy. I went to college in the analog days. When I went to college, digital signals were just getting started. And I did study analog and digital processing. My first job was at Dolby. The company at the time was the super analog company. They had ways to make analog the best it could. I know analog. Analog can work amazingly well. And I got a slide for that later if we have time. but it's hard to make work in the field. And it's hard to make it work consistently when you have a rack full of gear. There's all kinds of interference, there's all kinds of issues, and it's particularly difficult to upgrade where everything is point to point analog. And you say, okay, you know what? We want to add two zones. Now you got to rip everything apart, you got to reconnect everything. In the world of networked audio, you just add the zones as long as there's a network connection and you know how to interface it, you're done. And the quality of the audio is superb. It's bit for bit. It's either, the 16-bit, if that's what you're starting with, all the way up to 24-bit or 32-bit, depending on what you're starting with. So ultimately, the goal being audio excellence, this is a way better way to go about doing integration of home cinemas, of music everywhere in the house, of distribution of AV everywhere in the house.
I think that's what blows it away is for so many of us, we look at the way that it gets programmed. But even like you said, you want to add another zone afterwards. You add another, a new amp, you're trying to do something else. And now you got to rewire everything in the back of the rack. And it becomes, a big nest in the back as you're ripping cables out, trying to, bundle them back up. If you're trying to do it, it takes a lot of time and often introduces other noise. Go ahead, Matt.
And on top of that, you have to do all of your audio connections. So, if you're looking at adding a secondary zone in a region of your house that's not right next to your rack closet, then you're talking about, drywall pulling, running wire across the house, dealing with all the, stud bays, insulation, all of those things. But what is the one thing that every brand new home has in every room? Network. Right? We're because we use so many things with it already, it's already built into our infrastructure. It's there. We just are tapping into it and utilizing it.
No, I think that makes perfect sense. And Matt, as you're talking about infrastructure and being able to grow it out, obviously, like I mentioned before, this isn't brand new, right? This isn't trust us, this is going to work. Brand new protocol invented yesterday. This has been around for a long time, like Anthony was saying, and has really been used almost as a standard on the commercial side. So, can you talk a little bit about how that works from a tech standpoint and why commercial has chosen to use this standard so much?
So, and I think that is the best segue possible for this because, at the end of the day, right? We asked people at the very beginning, you made the comment on, why we sell this, and we sell what we know, right? And I think there's another side of that, which is we sell what we're comfortable with. We sell what we trust because of our experience isn't going to have us roll trucks every other week because there's some random issue. And that's why I love the commercial side of this and looking at this because commercial has a different priority than we do in the home resi space. We like to pay attention and focus on performance and all these high performance, products that, because there's more complexity to them, have more things that can go wrong. But here's the beauty of it, right? In the commercial division, your priorities are rearranged. And the number one priority in the commercial division is that it always works. Because you can't have, a football game or a hockey game or whatever have you, and you're having intermittent sound issues and having things cut out, it's going to be an absolute disaster if, you have audio dropouts during the team's walkout song, for example, right? So, that's one of the things that I think that, everybody can really pull from is that, hey, this is trusted in the commercial space because it works and because it's reliable. And that's, in my opinion, one of the biggest things to take away from why we're looking at it for this instance. Now, the other thing to keep in mind that I would point out here is a little bit of perspective too, because, think of all of the, different devices that are networked into a big stadium complex, for example. Think of all of the different access points, all of the hundreds and hundreds of things that are talking to each other, the different networks that they have running in there, whether completely isolated or virtually isolated. That's way more equipment than we're ever going to see in a residential property. It just is. I mean, even if we're talking an 8,000 square foot home, you're still not going to be running all of the complex systems that, a massive sports complex is. So, to take away from that to a higher level, if it can work with all of the extra stuff going on, then that means it's going to be that much more reliable and stable in a residential sided project. And I think that that's something that, a lot of people really haven't considered when they're making the hesitation with it, right? Because we do, in the past have always, the new technology is what becomes our crucifix from time to time. So,
I wanted to add one thing. I don't know if this is if this is on anybody's mind, but it's like, well, that's commercial. They don't care about quality. Like, well, you could say that. It's true. In commercial, the main point is first reliability, enough quality that you understand what's being said, and enough quality that they're playing the music. You could argue that. However, really interestingly enough, at the signal level in the commercial space, all of the signal flow is the highest quality that's available to us today. Really interesting. So in all of those standards, again, if we have time, I'll page through all of this info. And in all of the standards that are built into audio over IP, the signal transfers are all lossless, all the way to the highest bit size and sampling frequency you can think of. They're even though you could argue they don't really need it. If you're just trying to light up a speaker over, that's hanging over the bleachers, what do you need? You could probably get away with 10-bit audio and 5 kilohertz bandwidth. They didn't go for that. They actually went for the biggest possible pipeline. Why? Because it's easy to do. Like, why would you compromise? It doesn't, the switches, all of the circuitry, everything that's there today, and even at low cost computing technology, can handle the highest rate, the highest quality of digital audio. So I just want to put a kibosh on anybody who's going, well, that's the commercial guys, they don't know. Well, for some reason, for a good reason, the guys who built those standards went for the highest available quality. So I do mean 32-bit, 192 kilohertz, which is stuff that is even unheard of in the residential space. With no distortions, no signal losses, nothing like that. It's all very robust, ultra high quality, ultra audiophile.
Obviously, the network switch plays a big piece in the networked audio. Is there any preferred network switches for distributing digital audio? And I know there's easy answers to this, and then there's more layered answers to this. But does anybody have any thoughts? And is anybody willing to say any brands that they have used, at least, if not swearing by them?
I'm going to start with a simple answer, and I'm going to ask Matthew to take it from here. The answer is generally not really. The demo we ran at CEDIA was intentionally running on a really basic bought on Amazon.com $200 or $300 gigabit switch, which are cheap. I forget, it was an IP link. I intentionally wanted to use something simple with no special management, nothing, and it ran flawlessly for the 4 days that we ran it. On a more advanced environment where you may have lots of different zones and lots of different things going on the network, you probably want to go, not because of audio over IP, but for proper network management processes, you probably want to go a few tiers up in sophistication of the switches. I will mention that there are companies who make dedicated audio and video over IP switches, which is, they take their regular product and then add a few bells and whistles on there, particularly for our needs. And I'll let Matthew take it from here.
The better quality equipment you have, the less chance that you're going to have any kind of, potential weird thing. But you can do this on commonplace equipment. As Anthony mentioned, the switch that we used at CEDIA was, a regular bought off the shelf piece. It was not specifically designed for audio over IP. I can tell you firsthand, because I do some of our, test stuff, and I've done testing and validation with stuff over audio over IP network on AES-67 and some Dante devices here in my own home. And I had that set up for a month's time running, never had any issues. And I was running it on a little Netgear RAX48, which is a $190 router. And that's one of the biggest things I think that is the most critical when you come into this realm and start setting these things up is doing it with intention for how you want to use it. So, for example, the mastering studio that I'm referring to actually has 3 different studio rooms, and they have one B-chain verification system, and it's using a Storm processor with an AOIP card. And what they actually do is that they have different configurations pre-done on their Dante controller. And so when they want to go from Studio A to Studio B, they just click a button, and then you seamlessly transfer an entire, 916 mixing environment to a completely separate room with a different system.
Yeah.
And
No,
that's it.
that's nuts.
They never have to go unplug a cable and hook up new patch bays. They never have to do anything other than click a button, walk to the next room, and you're it. It's done.
No, I love it. I love it. So really the answer becomes, obviously there's a few things to look at: managed switches versus non-managed switches. You need to understand what's happening in your switch. I think the other piece of that is it needs to be at least the quality level that you would normally put in your install. Don't put in if you wouldn't use it normally for your general networking, probably don't use it for this. But I think the big piece, and where a lot of the questions or concerns come into it, is when you get into things like video over IP. There's been times where, okay, well, I'm using this HD base T. It's throwing my HDMI, but I actually can't get the audio return to go back on it. I have to buy a different switch that does audio return. And I think that there's levels of complexity that integrators don't want to deal with because they don't want that truck roll, that really don't happen here.
And with video, you have an entire other world of things that you have to deal with, because you have EDID management, things like that, where when we're talking AES67 or Dante for an audio realm, you don't. Those things are not part of what we're doing. We're broadcasting RTP stream packets, which are an audio signal, but that's it. It doesn't have to lock in and sync all of these other items. And, it's being it's either whether it's sending Atmos content from a Dolby processor directly to the Storm, or broken out individual audio streams going to your separate channels for side surrounds and subwoofers and Atmos channels and all of those things. It's a lot simpler package that we're dealing with.
Sure.
And there's a lot, you don't have to have all of the synchronization things, as long as you have a clock reference that lines up, which is at the end of the day one of the most important things, right? That's why these mixing and mastering studios are using these digital networks, is because they can tie in their house clock, which is their master time frequency thing, and it's going to everything. It's going to their projector, it's going to their Pro Tools system, it's going to their audio interfaces. So everything is running off of this one device as far as a clock ratio and slaving to them. And it allows them to do everything, that all of their work and verification and screening in a flawless manner.
Anthony, we're talking about the hows and the whys. What about the what? What do we got to do?
Let's look at connection diagrams. This would be, I would say, an upscale home cinema. It happens to be, one of our Cinema 2, what we call a Cinema 2 package. It's what you would put like in between 600 and 800 square foot room. There are 3 front speakers. There's a set of wide channel speakers. There's two sets of side channel speakers, a set of back channel speakers. There's 4 tops and 4 subwoofers. This is kind of like what we had at CEDIA. Actually really similar to what was at CEDIA. And this would be the connection diagram. Now, in this connection diagram, there's a surround decoder, and there's all of these channels coming out of the surround decoder. If you're looking at the better ones, those are all balanced XLR connections that go into the power amps. Sometimes they're balanced XLR to XLR. Sometimes they're balanced XLR to barrier strip or Phoenix connectors. All of that's got to get wired up. In the traditional analog world, this is what it would look like. This is really what happens, which is that the surround processor gets connected to a network switch. All of the amps, if you are using audio over IP amps, get connected to the network switch. It doesn't really matter which port you use. Some people that are good at this just actually use a sequence so that you know that port number 4 of the network switch went to the 4th channel. Whatever, why not? But the interconnectivity is so much simpler, so much faster. So again, we're going from this to this, and you go, well, who cares? Whatever. What difference does that make? Well, you solve a lot of issues. I also took this interesting picture at CEDIA that's pretty dramatic. This is a Storm ISP32. This is what you would install in somebody's house if you had a really high channel count home cinema, 32 channels. And this is what it becomes in the new world. This is Storm's Evo 32. For one, it's 1U high less. Well, who cares? And for 2, there's this entire battleground of XLR connectors. Every single one of those, somebody in your firm is going to have to wire up, make sure the plus and minus are correct, make sure the shields are correct, make sure everything's correctly tied down and either Velcroed or zip tied to the rack to make sure it doesn't fall off and all this stuff. And all that goes away. Single connection here in the network side. Excuse me. There's a network connection still for control, and then there's a signal connection that's a single Cat6. This is a diagram of what would happen inside the speaker. This is not bleeding edge. The surround decoder that could be a Storm goes into a network switch. The output of the network switch feeds through a Cat6, goes into the speaker, and the input of the speaker has, usually in our case, the amplifier still have an analog backup, but the input has all of the crossover, all the EQ, all the network addressing, all of the signal processing is in that input signal, and the output of that goes to the amps that drive all of the speakers actively, very precisely, with really high quality. So the benefit of going to active speakers that take in a digital signal is it's more efficient, it's more precise, it's more flexible. You can change things without even having to get up out of your seat and reconnect any point. Ultimately leads to that goal of better sound quality. I think I'm going to continue on one thing while I've got this presentation going and just give you a quick summary of what analog connections are versus audio over IP. Is that okay, Brett?
Yeah, go for it.
Just to be clear, analog connections, the current state of the art, they can be pure. There is nothing wrong with an analog connection. Under laboratory conditions, you can get 120 dBo dynamic range and a bandwidth from 10 hertz to 30 kilohertz. There's nothing wrong with a properly done analog connection under laboratory conditions. Under real world conditions, in a rack where you're running, let's say 24 different wires are coming out of the surround processor and going to 24 different amplifier inputs, you can pick up noise and hum inside the rack. It's a very polluted, and the back of a rack is electroacoustically or electromagnetically a very polluted environment. So you can pick up noise and hum, and that dynamic range can go from 120 dB down to 90. If you don't connect things correctly from a ground and shielding point of view, you can have hum. And that noise and hum shows up in the room. And rather than have a really quiet room, you have a room with a quiescent background noise where you lose some of the finer detail of the signal. It doesn't always happen, but it does sometimes. If you are running long signals, so Matthew was talking about an example of somebody wanting to add a second zone somewhere else in the house, and now they have to cut holes into the walls and run things into the attic or the basement. Well, if those runs are more than 40 or 50 feet of line level signal, if you don't do them correctly and you don't use the right cables, you can end up with degradations. And the degradations could be high frequency losses, low frequency losses, all kinds of different things, and certainly pickup of noise and hum along the way. So additional to that, there are always connection errors. When you're talking about 24 channels going from a source to a receive, somebody's going to connect the wrong channel into the wrong port, or is going to connect the polarity wrong, or is going to not connect the shield correctly, is going to miss, in the case of a balanced line, is going to miss one of the legs, the plus or the minus. If it's missing the plus, now you have a signal that's 6 dB down and out of polarity. So it gets messy. And then finally, this is a thing that nobody ever talks about, but I run into all the time, is that it's fragile. What I mean by that is that the analog connections coming off an XLR connector going into a barrier strip are typically thin wires. They're 22 to 30 gauge wire. And when they're in the back of a rack with lots and lots of wires that you're finishing the connections on, or you're troubleshooting and you're bumping around in there, it's pretty easy to rip a wire right out of the connector. Like actually break it by mistake, because you have all of this force, all of this strength from the bundled wires, and you can rip things off. And I've often been on site after everything's wired up and I find, yeah, well, the right channel has got hum and it's down in level, and you go look and you find a little 30 gauge wire that's just been pulled right out of the connector. You switch that to audio over IP. First of all, I think we've said it, but I want to remind everybody that it's been around for a while. We're not talking about stuff that's scary new. It is bit for bit accurate in digital, so it's very pure. It's running a computer network, which has been around for a while, right? We're not inventing something new. You can run hundreds of audio channels and video through it, and all through relatively thin wiring. It eliminates the strategies of point-to-point connectivity, where there's a physical connection from one device to the other. Instead, the devices all go into a bus, into an IP bus, and they can be distributed however you want. and it introduces a flexibility of changes and upgrades. So you connect a rack like we did at CEDIA, and let's just say we want to have a second room at CEDIA. Imagine that. Let's just say we were dumb and we wanted to have a second theater demo, right? Well, we could just go directly from that rack to another rack through one Cat6 cable and then just distribute it from there, right? Nothing more complicated than that. It's immune to noise and hum and response errors. Now, I want to be clear here, if there's any real propeller heads in networking, you can actually have connectivity issues. It is possible to get to a point where the data, the eye patterns and the rest of the digital data gets degraded, but it's pretty hard. And really cool, really cool in audio over IP is you have tools where you can actually look at that goes, hey, the quality of signal on this particular port is not right. Go figure it out. And you find the patch cable that's bad or whatever. Maybe there's a switch with a bad port. Whereas in analog audio, now you have to bring out the oscilloscopes, distortion meters, and all kinds of really crazy gear to figure that out. There are no connectivity errors because let's say you connected the port that was supposed to go to the center channel amp, you connect it to the right channel amp. Who cares? During configuration of the I/O, the inputs and outputs, you'll just say, here's what goes there. IP connectivity can go really long runs. You could go miles as long as it's a network. And it's flexible. So the flexibility, the easy expansion, and the immunity to errors is just crazy. Finally, I'll say that if you wanted to add, I'm going back to what Matthew was saying, you want to do a second zone somewhere else at the end of the house, there's no new added wires needed other than what's ever local on the end zone because the network's there in the house. And if there's no network cable over there, it's pretty easy to put one in. That's how it's done. And that's how much simpler it all ends up being. It's essentially a panacea where you get potentially better quality in audio and video if you're going to do that in a much simpler process. And a simpler process means it's going to be more reliable. You're going to spend less time on site and less time doing maintenance calls.
How big is that sigh of frustration when you get the whole system hooked up, you turn everything on, and you've got this, ground hum or noise coming from a channel? The other benefit to this is a lot of the times when you're making these digital connections, these systems have checksum routines in place. For example, we go into, AS67 or a Dante controller or Animon, and we, point one channel to another on the receiving end. And I say, hey, this left channel is going to this amplifier. Part of it making that connection is to do a checksum routine, and it'll tell you right there if there's a problem before you even have the rest of the system powered up. And if you do have a problem, you know exactly where it is because it's telling you.
You hit on a key thing for me, and I know Anthony and I were talking about this before CEDIA, and that was one of the things that really hit on with me is, yeah, who hasn't had to deal with a 60 cycle hum, a ground loop hum?
Yeah.
This is typically hooked up with a non-grounded, cat cable, and that you can actually put the amplifiers in different rooms, and you're not dealing with those same issues. And if I can eliminate the hum in a room, or the fact that there might be hum in a room, that alone is the price of admission. That's why I need to be doing this. Right. I want to hit a couple of questions that are in here. So Sean Tolan asked real, kind of quick. I can answer this one. We talked about some brands already. But who's making the move in this space as it relates to distributed audio? So obviously, for a lot of guys, they may do 5, 10, 15 theaters a year, but they're doing whole home audio every day, right? And doing some media rooms. Sean, the biggest one that I can say, so I was talking with Joe Whitaker over at Origin Acoustics just before CEDIA, while he wasn't getting ready for his on-floor wedding. We were able to chat for a few minutes. I'm going to have him on. We'll have a bigger discussion on networked audio because this is such a huge topic. We're not going to hit it all today, but I wanted to focus on this because this is the big deal ones, right? I'm building a theater. I need this to work right. But Joe and I will also be talking about networked audio from a distributed audio standpoint. Because if you look at that, the reason we talk about it is like, that's a commercial application, right? You're in the stadium like Matt and Anthony were talking about before. That's your, one to many, going out there. And, this is where our home is just a smaller version of that. Damien is asking, Damien Martin, How are latency issues handled, both in the IP network and in a local DSP?
They are handled. And that's what's really cool is in the management of the systems inside Dante, for example, they're keeping track of latency all the way through so that at the end of the process, everything is still timing wise accurate. So that there is no, I'm sorry, so that you can actually build an entire stadium and everything is correctly polarized and phase maintained. It's that level of nitpickiness. And that's part of the standards is to actually be able to look at that and make sure, if there's a device over here that has a long latency, everybody else is delayed so that it all ends up being identical timing.
And you can see it in real time too. For example, if you open up your net, for example, at our system we had at CEDIA, we can actually open up, for example, we can go into the network, audio card in the StormAudio ISP and see and look at all these things in real time. And I'll tell you, the most that I ever see is 2 milliseconds. But here's the thing, because it's monitoring it, it's tracking it, and it's, making sure that everything is synced accordingly. And that's because everything has, well, like we said, a little bit ago, one clock that it's all adhering to. It's not a concern. Now, I have seen, deployments where I've gone on and we've taken a look and I'm like, hey, can we talk about your network? Because I'm seeing like 99 milliseconds of latency and that's unheard of. And we find that, something is trying to talk to those ports. And at that point, we implement some best practices and do some network separation, and it just immediately goes away and corrects itself.
Well, and Matt and Chris was asking a question on here that ties in directly with that. So is it preferred to have a switch that's isolated from the overall house network, which basically means should it have its own network switch rather than going into the normal network switch that's running the rest of the house?
And absolute best practices, if you've got the equipment and the budget to do it, 100%. It's never gonna to hurt you. It's only going to, give you another degree of protection and comfortability. What I would say a step down from that is creating a separate VLAN for those audio devices, right? That way you can point to it and talk to it from your regular computer and on the other network, but no other devices are able to look at those, different ports and what's being communicated between them. So you're looking at it from a control connection standpoint and nothing more.
Nope, that makes sense. So, a lot of the questions, I've got a question in here coming from Dallas. So asking about the quality of the D to A conversion. Obviously when we're talking about audiophile kind of equipment and, people love to talk about, good D to A and what you should be using, which sources actually have it in there. One of the things that I love is that you're reducing the amount of D to A's and A's to D's because it's running digital all the way till the amplifier. You're basically removing that. But Anthony, any other thoughts in that as it stands? I mean, is it just a simplification of it? What else do we have to look at?
So here again, that's a great question. Hi, Dallas. You may assume that a garden variety, I'm going to say ugly black box commercial amplifier or DSP product has a crappy D to A converter. You would assume it because why would they need anything better? Well, strangely enough, maybe because they sell it for enough money, maybe because the designers have a certain amount of ethics in what they do. I have found really, really high quality conversion in commercial, pro audio and commercial products, things that have surprised me actually with how good they are, that rival the products that are sold for way, way, way more money in the audiophile space. So don't just assume that because the brand of that DSP amplifier that's a Dante amp is something out of the commercial space or doesn't cost less, that there's any issues with the D to A converter. So what I mean by that is, you do blind listening tests and they have to be blind. You can't know what you're listening to, and you put 3 of these things one next to the other and you switch in a random ABC form. And you go, can you hear anything? Can you measure anything? Can you do it? And it's I would say at this point, that's not the right place to be worrying anymore. It used to be. But the stuff made by the better commercial contractors and or the residential derivatives of that is truly fine, no noise, no distortion, no edginess, no nothing.
Yeah, I mean, Anthony and I were working on a project, and they're using, a simple analog to Dante encoder to feed a separate input device to us, which in this case is a DJ mixing table. And it's, I think the encoder piece is maybe $100 or $200, and it has great performance on it on the D to A conversion sides.
Hey, from a security standpoint, you guys, so obviously if, we just talked about possibly putting it onto its own network so that it's not on the same, or splitting it off a little bit. But obviously, a lot of consumers nowadays, especially if they're working from home, they've got their laptops and computers on that same network. Are there any security issues or anything that we need to look at? David was asking this. Now they're all of a sudden they're putting networked amplifiers and obviously processors, which most processors are at least networked at this point, in some way. Even for updates. Are there any security risks or anything that we should be paying attention to?
Not
I'm thinking.
Sounds like
not to my immediate knowledge. I mean,
everything's locked down, same as everything else, right?
right. I mean, at the end of the day, why do people get into networks, right? It's to steal information, to put you at a disadvantage, to mess your system up. I mean, if somebody wanted to, if there was a really good hacker that was out there that wanted to come in and rewire my theater, chances are I'm going to figure out when I turn it on, and I'm just going to reload my config file. And I'm glad you spent a lot of time of your life doing that.
Yeah, that would be so
switch
mean.
my left to my right.
That would be so mean to switch those left rights or put the center channel, at the top. Oh my God.
Trevor, now you have a prank you can play the next time you're at the
That's right, Trevor,
yeah
let's
showroom
go.
there.
We got this. We're gonna have the LCRs coming out the back, and center channel turns to the voice of God, and we're all
Hey,
set. So
I know for a fact Anthony leaves that system on.
that's
Absolutely.
Matthew will be talking after this. As we talk about these and we've kind of been talking about general networked audio. Anthony touched briefly on kind of the names of the different systems, but obviously the biggest ones, and I think you guys both work with both of them. AES 67 is kind of the base standard protocol. And then other brands like Dante are kind of built on top of that. They're using AES 67, but they have their own pieces. Is there one that, they're asking pros and cons or which one's better? And I know there's probably answers on both sides, but what do you guys normally look at in a system? Is it AES 67 is fine? Is it something special that Dante does that you guys want to highlight?
So, I think we can kind of, tackle both Craig and Connie's questions here at the same time. As you mentioned, AES 67 Dante are very similar. Dante is actually a subset of the AES 67 protocol. In the olden original Dante days, there would actually be a slightly different chip that was used that would sometimes prevent interconnectivity. Nowadays, that's not the case. So pretty much every single Dante device that's out there has the ability to do AES 67. And what you do is you just go into the Dante controller and modify the setting and say enable AES 67 mode. I've actually only seen one piece so far. I've seen two pieces that I didn't see the option on. The first one was in the actual mixing and mastering studio environment, and we actually just called the manufacturer and they said, I don't know why that's not available. Here, try this firmware, and it fixed our problem. The second was an older piece of equipment, and this is actually on a project that Anthony and I were both on. And that was, I think, because it was a little bit of a dated piece of technology that was using one of those previous chips that wasn't available to activate AES 67 mode. But in today's modern equipment, every one of those units should be able to talk to each other. Now, as far as the difference between AES 67 and Dante, for us on our side and assisting with deployments, the biggest variation between them is the control parameters that we use to set them up. So, if we're in an Anemon realm, everything's done within Anemon, and we don't have to do anything else. So all the gear self-discovers. You create a clock leader, and you tell things what you want them to point to. Dante, we do the exact same thing. We just do it in the Dante controller, and I have to go into our platform and create the RTP stream packets. That's the one thing that we have to do on our end is create that for Dante.
So now translate a little bit. What's Anemon? Just Anemon is a piece of software, control software that allows to go into the network, look at the network of all these devices, and go, oh, I see all these sources, I see all these receives, and I'm going to interconnect them this way and this way. The signal over here is going to go to there. That's a piece of software called Anemon that you have to pay a little bit of money for. If you're doing everything Dante, there is a control software that's free called Dante Controller. So I'm going to expand a little bit on what Matthew said, and I'm going to go back in history. You go back to the 90s, in the beginning of this whole thing. There actually were a number of disparate audio over IP initiatives, all of which coded the signal and streamed it differently. They all were their own thing. CobraNet was a really early one, and a CobraNet product connected to another CobraNet product. That was it. And then there was other organizations at the time. I think there was a thing called Ether Sound. It was different, and you couldn't make those talk to each other. Dante was its own thing. It was its own approach. And then there were others. So there started to be this progression, this evolution, where there were all these little islands of audio over IP, none of which could talk to each other, and all of which were just kind of stuck in their corner going, well, if you want to use Dante, all the products in your whole system need to be Dante. Or if you want to use Ravenna, which was a different source of technology licensing, it all has to be Ravenna. And in 2010, a bunch of propeller heads at the Audio Engineering Society said, ooh, this is not good. This is going to get really ugly if there's an incompatibility game going on. The most common one being that people may still remember the beta versus VHS battle, or in the world of cinema, all the different formats of audio, of sound and picture. That always leads to a crash. And so with good historical background and good wisdom, they said, let's all agree that there's a bunch of things. So this is all the companies that provide audio over IP, that provide all these features. Let's all agree that all these features are really cool, but that at the core of it, the transport layer, how bits are coded and transported from one product to the other, let's all agree to a standard so that a Dante product can talk to a Ravenna product. Once the source and the destination have done their thing, then you have other features that you can enable. And it took 3 years of investigating and discussing from 2020 to 2013. And in 2013, a standard for transport, the most basic layer of this, which is here's how a signal is going to get packetized and streamed and transferred. It came out, and it's called AES 67. So in itself, AES 67 is just an agreed upon language. You want to think of it that way. It's sort of the Esperanto, if anybody remembers what that means.
Lantos, aluminum, Kelly.
The Esperanto of audio over IP, a mishmash of lots of different ideas and standards that all came together where everybody agreed to it. And Dante very, quickly announced a change of its firmware, chipsets, et cetera, to conform to that. And so did other manufacturers. And so AES 67 in itself is not really a networking standard. It's a language that everybody agrees that, hey, you're feeding the signal into the network, and it's all the same thing. Now, and I have lots of slides on this. I won't even go there. Believe it or not, Brett, I won't turn on my PowerPoint. But can I share screen again? I do have a list of actually. Let me go to that. I said I won't, but I'm going to do it anyway. Let me share screen on two interesting things here. So here's a bunch of alphabet soup on audio over IP. Dante, Ravenna, QLAN, Livewire, AES67, others. A bunch of different people are doing this. And this here is the industry neutral agreement on once everybody's done doing their thing, we're all agreeing we're going to pipeline it through this standardized scheme so that everything can talk to everything else. I will say there's really amazing resources on the audinate.com website that explains all of this. You can just go navigate around and pick up a whole bunch of papers I will say that Dante is the market leader. There's 500 licensed manufacturers. There's about 3,500 products that go from a single channel microphone to a 500 channel more mixer. And they have a lot of really cool features. But where I wanted to go to is this set of slides, AES 67. What does it control? What does it cover? And it covers the synchronization, the clock synchronization between products. And so there's an agreement. The products all log into it. Somebody like Matthew looks at it and goes, y'all here, you're going to be the master clock and you're going to synchronize to all of the other ones. In digital, we all have to be in agreement as when the clock is ticking. It governs the transportation of bits. It governs the encoding and streaming options for the bits. There's not just one, but it governs what they are. And then it governs the connection management, which is how do you tell a source that you've got those signals, and how do you tell a destination those signals are going over here, and make sure everybody's using the same metadata. And then it governs the description of the streaming so that the receive can go, oh, I just see this coming in. It's this kind of signal. What it does not cover, and this is interesting, it doesn't cover discovery. And this is a thing that Matthew spends a lot of his time dealing with, as opposed to in Dante, where you connect all of the products together and you open the Dante controller. And if the network all works right, you go discover, you see all of the products and you go, oh, okay, so here's all my sources, here's all my receives. For this configuration, I want this signal to go there, that signal to go here, and you're building a virtual matrix in the Dante controller. AES 67 there's no AES 67 thing that does that. So then you have to rely on third-party software like Anomon to go, okay, well, so I've got these signals here and I got those things there, and you patch them together. It doesn't govern the control mechanisms for these IOs and other things that are, product A, they may be controlling product B. It doesn't cover device management, and it doesn't cover streaming qualifications. So what I mean by that is there's really cool features in Dante and other ones of the schemes where you can monitor the stream. It's like, am I losing any bits? Is the packet good? Is what's getting to the DDA at the end an interpolated version of what started, or is it all clean? That's not written into the AES 67 standard or any of those protocols because it's not needed. That's all the work of the other companies do that. So finally, I'm going to say, well, what do you choose? What do you go for? Well, I'm gonna put it simply. If the system is pretty simple, like what we did at CEDIA, where there's a surround processor that's feeding through a simple network switch a bunch of amps, and there aren't 25 other zones and lots of other stuff going on. It's pretty simple. You don't really need to go for one of the higher level protocols, and you can stay at the base level of AES 67, which means that the products all need to conform to AES 67 without any of the other expensive or more expensive licensed overlays, right? So you just know, hey, I know my source processor, the Storm Evo in this case, is going to go to these PowerSoft amps, and it's going to be pretty basic. I don't need anything more. Matthew's going to come along and he's going to open his interface that's built right into the Storm and go, okay, I want my left output to go to this amp. I want the center output to go to that amp, the right output to go to this amp. Boom, 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 done, finished. It is okay at that point to go to the base level, just transport interface agreement between the source device or source devices and the receive. If you're going for things that are more sophisticated, like a big house with 25 zones and lots of stuff going on, you may want to consider going up to either Dante, Ravenna, or something else in which you've got, I'm going to call them digital hall monitors, essentially, that are just, checking, is everything's okay? Everything's okay. Okay, we're all good. We're all good. We're all good. Because that will result in less truck rolls and less issues. And if you look at, in the case of PowerSoft, the amps we use, the analog amps are this much. The AES amps are just slightly above it. And then the Dante amps are just slightly more expensive. The difference in price is not even worth scratching your head. It's pretty minimal. Matthew, would you agree with all of this message?
Yes, I would. And I would also comment, because I believe we're doing this on that project in NorCal together, that those things are, entirely exclusive. Like, we have Dante feeding the Storm ISP, and we're running AES 67 out to the PowerSoft amplifiers.
No, I mean, that's great. And I think that's one of the biggest issues in our industry in general is that we feel like there's so many protocols and everybody wants their own, we'll say IP, but in the different route, right?
You know what the great thing
Intellectual
about
property, yeah.
standards is, right? There's so many of them to
Yeah,
choose
I'll
from.
go there.
That's right. That's right. There are plenty, and nobody requires you to actually use them. So I love when I hear the idea of platforms where, like Anthony, you're saying, I love the idea of having discoverability and things like that, hey, maybe is available in Dante, but they're all still using that same core AES 67 for transport, which means, just like you were saying too, Matthew, that, I can mix and match a little bit in there. So if I have different pieces, they're still speaking the same language. Certain products are just going to have a little bit more capability in there. And I think that's perfect. Now, Damien asks a great question in here again. This is happening more and more. Obviously, a lot of houses are wired with network wiring in all the rooms, anything that's newer. However, we can't ignore the fact that there are mesh networks everywhere, either in older homes or places where network cables weren't installed. And so often people are extending their networks where they're using, basically wireless. But then there's again, a small network port that plugs in typically and has a couple of outputs in addition to wireless. How well would that work in this? Matthew, have you seen issues? Have you seen this attempted?
I haven't actually been involved in a project that's used Wi-Fi transports. I would step back a little bit, I suppose, because we are also the StormAudio ISP, and all StormAudio processors are Roon certified endpoint. I have seen people try to connect a, little wireless network dongle to the back of the unit, which for control purposes is probably okay. I don't know if I'd run a calibration that way. And then call and say, hey, every once in a while we get a little bit of oddity. And it's like, well, let's look at that, because if you've got a little Wi-Fi dongle and it's attached to the back of the unit, chances are that's in a rack, it's in a cupboard. It's not really in a position for Wi-Fi best practices to begin with. So I would say to, use a degree of caution. I'm sure that we will start to see more solutions for things like this, because it's one of the adaptability things, right? Once you see tech take a step and kind of get its foothold, then you see adaptabilities and commodities come downstream in the market. So I'm sure that we'll see them. I'm sure that, as things get better, like I was reading an article this morning on, how much better streaming content has gotten. And there's some of us who are, a little bit more of the old school purist theology and are, never going to, go for an Apple TV over a Kaleidoscape system. But I think, as technology in our current state of the world advances, we're getting more to a point where those are going to be commonplace. We're going to see them more. But to be fully honest, and every time I say that, I have an old mentor in the back of my head going, you should never say that, because that means that you're not honest at some points. But it's an expression we're all used to. So it's a habit, unfortunately. But I just want you guys to know I do have that voice. To be honest, haven't had the experience with them.
Yeah, so I've tried it. It is, if you start reading through the documentation, they clearly tell you this is not made for Wi-Fi. And it's not a question of bandwidth. It's a question of the quality of service and the continued, the audio is packetized. The whole idea of IP is you take chunks of the digital audio that's normally a stream, you packetize it, you send it out. And if the packetizing is not a continuous flow, there's places where there's dropout. So I actually tried this. I don't know if I mentioned this to you, Matthew. I took the left-right output of a Storm processor running AOIP and jammed it through our network to a remote wireless connection over to our warehouse. That's a hop across the parking lot. It's not even Wi-Fi. It's actually a dedicated hop. And then ran it through Wi-Fi on the other end to see what happens. Then there was audio, and it would be playing, and then once in a while it'd go, and then it would come back, and then it would play, and there was not a consistent time for it. It was just like it'd be fine, and then it would go away. And if you look at the link itself, the bandwidth of the link, it was a good 200 or 300 megabits per second, not a problem. It's not made for the right quality of service with enough streaming continuity for the thing to work. Doesn't mean that will never happen. Just right now, I would not rely on that.
Well, and especially the whole point in this is how reliable it is, right? As we talk about the commercial applications and the rest, and I'll throw in one little tidbit in there as well, which is from the Kaleidoscape side, which obviously uses higher bandwidth than audio. By far, I actually did a project with Todd Anderson over at AV Nirvana, where we did a case study, and so one of the things was going into multi-room. And so his theater downstairs, it's obviously networked right in, not a problem. But we wanted to get it up into a bedroom upstairs, and so using a mesh network, we tried it. And obviously, from a corporate standpoint, I qualified it and said, "Do not do this at home." And I told them, like, in an article, I need it to be related. Do not try this at home because we can't guarantee it, right? There's going to be dropouts. There's some packets not going to make it. And especially when you get into video, now you get into EDID drops and all that kind of stuff. But it did work, and like I said, he didn't have too many problems with it. So I think it's one of those things where, I wouldn't recommend it. I wouldn't, if at all possible, I wouldn't spec that into a client's home because you're going to get a truck roll at some point with it or a phone call at some point. But if somebody knows that and says, but I really want it in my kid's room or, some sort of secondary room that's maybe not as important, I think you can try it and just make sure that you qualify it generously in there. So,
yeah. And to also add on that, there's one thing that actually just popped in my head too, which was we mentioned beforehand that these things have checksum routines in place, right? Mm-hmm. They're constantly checking on themselves. And, Anthony's story about, testing with that, with your warehouse across the parking lot reminded me of something on one of my first studio projects, which is that little click. That's a clock desynchronization. And that's the system saying, hey, I'm not in sync. And it's actually disabling the audio pass through because it's registering that there's a problem. And then when it resyncs, it's going to re-enable the audio playback. But that is what that experience was. Most likely.
Plus, with Wi-Fi, you expose yourself to somebody breaking in and changing the channel of your center into top.
That's right.
Yeah. You expose yourself to Trevor.
So Ricardo had asked, and I may just kind of take this and take it offline to it. But basically, he was asking IP-enabled speaker options for distributed audio, more specifically PoE-powered speakers, which has always been like the great thing that we all want, a speaker that I don't have to plug in, that I can kind of place anywhere, just run with the network cable. I think that that's a question that we would probably put into a distributed audio discussion because we can talk more deeply about it.
That was going to be my comment. Is I don't know that the PoE power is available for a proper theater.
When we're talking about residential, if they want the clarity, if they want those other pieces, again, you're still usually looking at something that has some sort of outboard amplifier that you can rack mount. That then you're just running speaker cable going into the room from there. And obviously, if we get into a theater application, you need a lot more horsepower and headroom. And that's something that PoE just can't really do at this point. If you have questions on Grimani Systems products, or you're looking at a theater, I've always been a big proponent of this. You don't have to go it alone. Yeah. There's a reason why the top theater winners, when you look at CEDIA wins every year, happen to be Anthony decided to leave us for a little bit.
I think his son's visiting.
There you go.
No, I got a visitor.
There we go. So, as we look at those opportunities, as you look at your first networked audio system, having somebody support you like Anthony Grimani and his team over at Grimani Systems, same as I know with Storm. If I have a question on that, I'm probably going to get Matthew, or I'm going to get other people that know what they're talking about. Go ahead.
Yeah. And on that note too, one of our philosophies here at StormAudio is bettering the industry any way we can. So, if it's a conversation that, you guys have about this, or you have any questions, or best practices, suggestions, or, general conversation, by all means, you're more than willing to reach out to myself or to my counterpart, Gary Blouse, because for us, it's, if we can, have a conversation with you that's going to better the work that you do and better the industry, even if it doesn't use a StormAudio product, we're all for that. So
if you have any questions, like I said, we keep this educational for the most part, but these products are great, you guys. They wouldn't be on here if they weren't. And what I love the best is there are good products out there. Anthony's always the first to say there are other good speaker manufacturers out there. However, when push comes to shove, and like Trevor said, I want more people on my team, having people like Grimani Systems with an Anthony Grimani or a Matthew Trinkline, that's going to be the benefit. That's the benefit. If all products are great, that's table stakes of getting out there. I want to build my team out with an all-star cast and being able to tell my client, you know what, we are going to do an amazing theater for you. And because of that, I want to recommend that we bring in, Anthony Grimani of Grimani Systems, here's some stuff, or even understanding acoustics, room design, and the rest. So definitely feel free to reach out for any of that you guys need. We've got some great resources here for you. Tony Baker, somebody's got to always have especially if we're talking about cables and connections, you got to have a monster cable, little comment on there, right? So yes, you can expect the very high-end turbine terminated monster cable Ethernet cable coming out soon. I will let Noel know your thoughts on that, Tony, and I'm sure we can get some gold-plated something in there. I think we've covered pretty much everything. Jeff had mentioned, and I think we kind of talked about this, but the differences in the source material, analog versus AOIP network sample rates. The answer is we're not D-to-A-ing as much. We have internal clocks. We have all these feature sets with a digital source. Whatever the source is running, digital audio should be able to pass that through all the way through the end. Is that a fair statement?
Yeah.
I'd say that's a good statement. Actually, you could even take that further. If you do want to have control over what the DA converters are because you like to play with that, this is a way to do it. Because who else is going to make a surround processor or a multi-channel preamplifier controller that gives you digital outs? Once you have availability of networked audio, there are ways to take that network audio, right, and convert it into a signal that you can plug into an external D2A converter. There's a whole bunch of interface boxes out there. They would take AOIP and turn it into I2C, into optical, turn it into this, turn it into that, whatever you need to plug into your DA converter, and you can do that.
This has been a great conversation in here. So Anthony, Trevor, thank you very much. Matthew, thank you very much as well from the StormAudio side. We appreciate all the time. Thank you guys very much.
Thank you.
Have a great day,
Thanks, everybody. Thank you.
Bye.
Bye-bye. Didn't I tell you this was going to be a good one? I'm super amazed at the way this technology simplifies installation and troubleshooting versus traditional home theater design. Be sure to drop a comment to let me know what you think. And if you found this video beneficial, please like and subscribe so I know to keep making more. Also, if you didn't watch them yet, be sure to check out the first 2 videos of this series, where we offer the definitive course on bass management, and the other video actually walks through the design of an award-winning CEDIA Expo demo theater. Both of these are can't miss. Again, I'm Brett Bjorkquist, head Facnatic, and welcome to the Fac'n family.